Okay, today we're going to take a look at the other way of balancing redox reactions, and this is called the half reaction method, or sometimes it's called the half cell method. And like before, you get a chemical reaction that's not balanced, and it will tell you whether or not it's in this acidic or basic. So rather than go through all the three different types of possibilities for balancing a redox reaction with this method, I'm just going to do the acidic solution one. So, like the oxidation number method of balancing redox reactions, first we need to put on our oxidation numbers. So let's go through right there and do that right now. And that would be plus 5. Okay, now what we're going to do this time is we're going to identify again where the oxidation and reduction is. So we look at Cl on the reactant side and we look at Cl on the product side, and we notice that the number has gone from plus 7 to minus 1. So let's just label that as we're just going to call that the reduction. And if we look at oxygen, it went from minus 2 to minus 2, so that's not involved in the redox reaction. So let's take a look at nitrogen, and we see that nitrogen has gone from plus 4 to plus 5. So that is a loss of electrons. So we've got an oxidation. Okay, now what we're going to do is we're going to balance this reaction, but what we're going to do is we're going to balance each side separately. And what I mean by, I guess side is the wrong word. We're going to balance the reduction half and the oxidation half independently. So if you look on your in your notes, there was a very simple one at the top of the page. It's K plus Cl makes KCl, and you can see there that I've gone through all the steps. Follow the numbers about the order of the way I completed that sort of question. And you'll see that the main idea is that I need to cancel the electrons when I add up the two equations. And you can see in your notes that that's what eventually happens. So what we're going to do in this way of balancing this redox reaction is we are going to split the two sides up into oxidation and reduction. And I'm going to start with the reduction. And we're going to put reduction on the left-hand side of your page. So sort of about, I don't know if this is your page, about right about here, just write the word reduction. And then over here, I want you to write the word oxidation. Now, there's a reason why I suggested really that we put reduction on the left-hand side and oxidation on the right-hand side, because there is going to be sort of checks and balances put in place to the way we're doing this to see if we're doing it correctly as we go along. And you'll see what I mean as we work through this question. So what I want to do with the reduction is, hopefully by now you understand that when you have a reduction, that the electrons are going to be on the reactant side of the half reaction. And if you don't know what I mean, take a look up at the example in the A part where I said balancing simple half reactions. And if you look at the reduction half reaction, you see that you have 2 electrons beside the Cl2. So it's on the reactant side. So if we pretend, we'll just make a little arrow here. If we pretend that this is a chemical reaction, just put a little E on that side of the arrow, which represents the reactants. And what we're going to do on this side is we'll make another little arrow as well. And since in oxidation you always have your electrons as a product, what we'll do is sort of just put an electron symbol right there. And we'll come back and we'll see how that is going to help us as we go through each half here. Now what we do here is we're just going to take the reactant and go to the product. So we're going to look at the reduction side first. So the reactant in the reduction is ClO4 minus. So you're going to want to put this one just a little bit, but right here. You don't want to put too far to the left of your page. So I'm going to stick it right here. ClO4 1 minus. And it goes to Cl minus. So I'm just going to put an arrow here. Cl minus. I'll do the same thing with oxidation. The reactant is NO2 going to NO3. So we'll just write that as well. So we'll put NO2 is going to go to NO3 minus. Okay, now on your page you have balancing more difficult half reactions, and I've got steps 1 to 9. And so we've completed step 1, which if you look on your sheet, it says assign oxidation numbers and then say which half is the oxidation and which half is the reduction. We're finished number 2, and we're sort of working through number 3 right now. Now what I want you to do in your notes is somehow highlight number 4 in your notes and put a star beside it, circle it, because this is something that people tend to make a mistake on. What we want to do first in here, and this isn't an example of one, but what we want to do first is we want to balance any other atom besides oxygen or hydrogen. So we have our chlorines balanced, which is good, and we've got our N balanced, which is good. So what I'm saying in 4 is not applying in this particular case. I'll just do a little example in the middle here. I'm going to put this fairly small. For example, if I had ClO4 1 minus, and let's just say it went to Cl2, the first thing that you're going to want to do is put a 2 right there. And the reason you're going to do that, by putting that 2 there, you'll notice now that you went from having 4 without that 2 there, from having 4 oxygens on the left side to now having 8. That's important because the next step that we're going to do here is we are going to balance the oxygens. So just like in the oxidation number method, to balance oxygens, we add water. And so we're going to add 4 H2O to this side. And so I'm just going to put that as a square. Now by adding that 4 H2O, you'll see now that I have now 8 hydrogens on my right hand side. Well, what I have to do is I have to go now and put 8 H pluses onto the left hand side, I should say. Now I'm going to do this in steps, just so that when you look back at this, you can see what's happening in each step. So what I want to do in this step is put 8 H pluses. So just like we did in the oxidation number method, we put 8 H pluses to balance our hydrogens. Now what we want to do, I'll put a square around that. And I'm going to rewrite it because we're going to do one more step. All right. Now what I said, if you recall, for the oxidation number method, I think it's when we did the neutral version of it, I had said never in your final answer do you ever see electrons. Never use electrons to balance your final reaction, the charge. Well, this isn't the final reaction. This is only the reduction half. So we need to see electrons in here. Now the reason I put the E up here on the left hand side of the arrow is because this is sort of a prediction. If I've done all this work correctly or reasonably correctly, I'm not saying maybe you can make two mistakes and the two mistakes cancel each other out, but usually that doesn't happen. This is predicting that I am going to have to add electrons to the left side of the half cell when I'm balancing. So this side here. So let's take a look at how many electrons I need to add to this, and am I going to add them to the left side. So the right hand side has a total charge of -1. The left hand side has a total charge now of +7. 8 plus 1 minus gives us +7. So the only thing we can do is add electrons. So I've got too much positivity here. Maybe I'll just sort of put that. Where can I put this? I'll put it up here. This side is now -1, and this side is now +7. So I need to get these two charges to be exactly the same. So what do I need to do? The only thing I can do is add electrons. If I add 8 electrons to the left side, 8 negative right here plus 8 positive adds up to 0. And now, I'll just cancel that, I now have -1 right here, -1. And so the charge balances. Now the other thing is, you see now that my prediction of having the electrons on the left-hand side has come true. So I'm reasonably sure that I have done the work up here correctly. Now before I get over to the oxidation side, I want to go back to this right here. So if this was our scenario where we had ClO4 1- going to Cl2, if you forget to put that 2 in here, what you're going to put on this side would be 4H2O. Now remember, that's if the 2 wasn't there. And that would give us 4 O's and 4 O's. Now, you would go along, I'm just going to scribble this out, you would go along and balance this and put 8 H pluses on the other side, like we did here, and you'd run into a problem later on with your charge, because this should have been a 2, which means I should have added, I've got 8 oxygen here, I really should have added 8 waters. And so that's going to affect your number of hydrogens that you add, and because hydrogens, if we look over here, are positive, it's going to mess up your charge. So again, number 4 in your notes, highlight it and make sure that you do that one first. The reason people make mistakes is because it doesn't happen all the time. It's not sort of something you do every question, but it's something you need to be aware of. Okay, let's go over and do the oxidation side now. I've got my N's are the same, which is good, but my oxygens are not balanced. So what I need to do is make sure that I have the right number of oxygens. So I'm going to put 1 water on the reactant side, because now I have 3 oxygens and I have 3 oxygens. Well, I've added my 2 H pluses, so I'm just going to rewrite this like I did before. Plus NO2 makes NO3 minus. And what I need to do now is I need to balance my hydrogens by adding H plus, just like that. So I've added the H plus on this. And finally, I'm going to need to add my electrons. Since this is the oxidation half, I should have electrons on the reactant side, somewhere here. Because if you look up here, this is what we predicted, is that when we do all this work here, I'm going to have to stick in electrons. If I've done it correctly, this work, I should get electrons on this side. So I need to be looking at putting electrons here. The question is, how many do I need to add? So if we look at this side is neutral. it has 0 charge. This side right now adds up to +1. So I need to get this +1 down to 0. By adding 1 electron, I will achieve that, because now I've got -1 from the NO3 plus -1 from 1 electron gives us -2 plus 2 H pluses adds up to 0. So we see electrons in our equations, and this is what we should have because we're only looking at half the reaction right now. Well, like the simple example on your previous page, if you want to look back at A, we need to add these two equations together. But when we add these two equations together, I need to have my electrons cancel. And that's not going to happen right now. Sort of think like Hess's law. If I were to put this one underneath here, I've got 8 electrons on my reactant side, but 1 electron on my product side. They're not going to cancel. I'm going to have 7 left over here. So what I'm going to do again is an LCM, the lowest common multiple. So what's the lowest common multiple that 8 and 1 go into? It's 8. Now, what do you have to multiply 8 by to get to 8? Well, 1. And what do you have to multiply 1 by to get to 8? 8. So it looks very similar to the oxidation method, but we're going to do something a little bit different. It's kind of look sort of more like Hess's law. What I want you to do is let's call this one equation 1 and this one equation 2. So what we really need to do is we need to multiply equation 2 by 8 and equation 1, this one, by 1. So I'm just going to go to the next page so it's not squished. So we're going to go equation 8 times equation number 1. So that gives us 8H2O. Nope, that's not right. Let's see here. Equation 1 is, oh, this one, right. Yeah, 8H2O. Sorry, my notes have it backwards. So 8H2O plus, I guess that's reaction 2 then, isn't it? Let's make that reaction 2. That's why my notes are backwards. So looking above, you've got reaction 2 is the one with the waters in it. So 8H2O plus 8NO2 forms 8NO3 minus plus 16H plus now we have 8 electrons. And now we're going to take equation 1 and times it by 1. So we've got our 8 electrons up there plus 8 H pluses, ClO4 minus, Cl minus plus 4 H2O. And what we want to do is just add it up. So there's various ways of doing this. What I like to do is sort of like what we did in Hess's law, and that is cancel some of the stuff that we can cancel here. So I've got 8H pluses here and 16 here, which will make this go to 8H plus. And I've got 8 waters here and 4 waters here, so I'll have 4 waters left over. And the most important part of this whole process is that we cancel the electrons. So whatever you do, number one is that we should be canceling these electrons. And with what we've got left should be our final balanced equation. So we have 4H2O plus 8NO2, and I'm just getting that from right here. But our other reactant is here. So I'm just putting all this stuff on this side of the arrow, the reactant side of the arrow, on one side. So that's plus ClO4. 1 minus. And then I'm just going to put all this stuff that's left on this side. And the order doesn't really matter, so I'm just going to use the stuff on the top. Cl minus. Now the key thing here is, since this is an acidic solution, we need to have H plus. So H plus equals acidic. That's a good thing. If somehow your H pluses cancel, you just made a mistake somewhere. So we need to have H pluses floating around if it's in acidic solution. Now let's just go through and if we counted our atoms, I've got 8 H's on the reactant side, 8 H's on the product side. I've got 4 O's plus 16 O's plus 4 O's. 16 plus 4 is 20 plus 4 is 24 oxygens. 8 times 3, 24 oxygen. 8N, 8N. 1 Cl, 1 Cl. And now let's just make sure that our charge is correct. This side, entire side, has a charge of -1. And this side also has a charge of -1 because these 8 negatives plus 8 positives cancel each other out. And I'm only left with 1 negative right here, the Cl minus. So that's -1 as well. So we've got our charge balance, and we've got all our elements balanced, and we've got our acidic left over. We are finished. Now I'm just going to go back to the previous slide and just show you how this would be different if this was in basic solution. So if this were in basic solution, what would happen is before you added the electrons, just like in the oxidation number method, you would add 8 OHs to each side. So that would be the next step. Then you would add the electrons. So you want to start with I'll just sort of summarize, I guess. You want to start with any other atom besides oxygen or hydrogen balanced. So in this case, Cl, Cl, done. Then you want to do oxygen. Then you want to do hydrogen. And if we're in a basic solution, then you want to get rid of the H plus by adding OH minus. Then you put the electrons. The electrons are always the last thing that you put before the LCM. And that is how we do, using the half reaction or half cell method, how we can balance a redox reaction.